For this week 5, we're going to go ahead and talk about hypothesis testing. This is the next step in inferential statistics. Last week we talked about how to estimate unknown population parameters using sample data. This week we're going to start talking about a procedure that will allow us to determine if a claim about a population parameter is supported by actual sample data. So last time we didn't know the population value and we were using sample data to estimate it. With hypothesis testing, someone else has made a statement about a population value and we are using sample data to check the validity of that statement. These types of tests are also sometimes called significance tests. And we will use a level of significance when we perform them. And we can perform them for lots of different population parameters. We can perform them on single variable data and multivariable data. And for most of the rest of this course, this is what we are focused on, is hypothesis testing. How do we test claims about population parameters? Specifically this week, we're going to start with claims about means and claims about proportions, which is a perfect follow-up for what we talked about last week with confidence intervals. For all of the hypothesis tests that we're going to perform in this course, we're going to use the same 6 steps. The first step will be to define the parameter of interest or parameters of interest, specifically in words using context from the problem. Am I testing a claim about a mean? What is the mean of? Are we talking about a mean height of high school students? Mean number of money spent at toll bridges in the Bay Area? Like, what kind of parameter are we talking about? And we should label the information that was given to us in the problem. Once we've identified everything that we're given and we've defined our parameter of interest, we are going to state the hypotheses for our hypothesis test. And there are 2, and we'll talk about them in a future video. These are based on the claim that we are testing. After we've stated the claim that we're testing, we're going to identify the appropriate distribution that we should use to perform this test. And these rules are going to follow the exact same rule set that we used last week for confidence intervals. We know for confidence intervals, if we are testing a claim about a mean and we know the population standard deviation, we're using the normal distribution. We know if we're testing about a claim about a proportion, we're using the normal distribution. If we're constructing a confidence interval for a mean and we don't know the population standard deviation, we were using the student t distribution. We're going to follow that same pattern here. If it's means and we know sigma, or if it's proportions, we're using the z-curve. If it's means and we don't know sigma, it's the t-curve. Once I know which distribution I'm using, I'm going to calculate something called a test value or test statistic and a p-value. And I'm going to draw a shaded label distribution illustrating those values. These values, the test statistic and p-value, are based on our sample data. I swear I know how to spell. Hang on. And based on where our sample data sits, we are going to make a decision about how likely it is for us to select that sample, assuming that the claim about the population is true. So based on where our sample data sits, we'll make a decision about our hypotheses, and then we will summarize our results. Over the next couple of videos in this series, we're going to look more closely at each of these steps, what the hypotheses are and how we write them, how we find test statistics and p-values, how we make decisions, how we summarize, including sentence frames that you can use to summarize. If you have any questions on this 6-step process, feel free to send me an email or drop by office hours. Otherwise, I will see you in our next video.